Okay, we can get started. Welcome back, everyone. Now we'll be starting with the second half of the operation and maintenance topic of day 3. We have a couple of more presentations and then discussion for half an hour after that. So Arn from J&W Cleaning Solutions will be presenting on fully automatic cleaning systems. You can go ahead and start your presentation, Arn.
Okay, thank you very much, Rishi, and the whole ACCU, the team, for giving us a chance and me the chance to present J&W Cleaning Solution today to you. And my point is to give you an induction into fully automatic cleaning, and mainly how much it influences the cleaning cycle and the cleaning philosophy of ACCs. For those of you who probably do not know J&W, I give a short introduction of the company. And J&W was founded in 1932. We are located in Bochum in Germany, and we have 2 business divisions. Since 1991, we are busy in machinery building and building engineering, design, and of cleaning systems for air-cooled heat exchangers. And we delivered worldwide 420 complete cleaning systems, including more than 3,000 cleaning chassis or cleaning rigs for the cleaning of air-cooled heat exchangers. And our second division is the cleaning service itself, with patented mobile cleaning systems, which we developed. We are cleaning air-cooled heat exchanger, and so that means with this mobile equipment, we go to the customer, to the cooler, we clean it, and afterwards we disassemble the equipment and go back home or to the next customer. This we are doing in Germany, in Europe, in South Africa since 1995, and also with our exclusive partner Conco in the United States since 2001. The company itself, as I said, is based in Germany, but we have subsidiaries mainly offering the services in France, in Italy, in South Africa, and also have a subsidiary in the Middle East. Well, our heart beats, of course, for engineering, and we have a very good and long-term experience engineering team, and we are delivering for all kind of air-cooled heat exchangers the solution for a cleaning system that fits optimized and way to the shape and the design and structure of the cooler. So we are offering the complete range of cleaning systems. That means, from our understanding, manual cleaning chassis or cleaning rigs, which is just more or less, if you like to say, a ladder where you have an access to the ACC, to the cooler, and with no additional cleaning devices on it. And this we are building also since 1991. Also since 1991, we developed semi-automatic cleaning systems, and already since now almost 10 years, we are delivering and designing fully automatic cleaning systems. And especially to the requirements of customers. We are doing a lot of special designs. You can see one on the slide with a platform on it, which is used for the exchange of segments from the ACC and supports this assembly and disassembly. It's even the longest and highest, let's say, chassis we delivered in the history. It's 18 meters long, so it's really a very special construction. Going a little bit more into detail about semi-automatic systems and the comparison to fully automatic systems. The cleaning process of semi-automatic cleaning systems requires an intensive handling of, as you can see on the picture on the right side, of minimum 2 operators, and the horizontal movement of the chassis is done manually. Cables, hoses have to be repositioned, and partially equipment has to be converted from one roof side to the next one. So that means during investment phase, usually the project team is a little bit short of budgets, and then sliding devices, drive units, nozzle beams only bought one piece. So you have to change it from one roof side to the other, move it from one chassis to the next. And so this is the work that has to be done. In comparison to it, the fully automatic cleaning system is definitely a robot. It works completely independent. So no operator is needed, which saves personal costs, of course, and increases work safety. So, and just by the way, when we are talking about semi-automatic system, that means the nozzle beam is driven by electric motor. It moves up and down, and it is, when you once started it, it is really moving automatically. So the operator has not to control if it's on the top, and then you have to find the right moment to stop it and to bring it down again. This is not our technology. It's fully automatic. It's sensor controlled. And if it's on the top, it stops, it goes down. If it's down, it goes up again. So it's nothing the operator has to control anymore. But of course, on a semi-automatic system, the horizontal movement of the rig has to be done manually and until step by step, until the whole ACC is cleaned. Fully automatic systems are, in opposite, really fully equipped, permanently, entirely, with all necessary equipment, all drive motors on each roof side, each chassis, each rig has a cleaning device, nozzle beams. It is completely equipped and ready to start. Each cleaning chassis is also, and the system, connected permanently to water and power supply. And the cleaning system and process are completely, really computer controlled. You have different programs that can be selected for the most efficient cleaning of the ACC. Therefore, the cleaning process can be started at any time without any setup or preparation. You just have to press the button and the system starts. And the start of the cleaning process can be done from the master control panel, which is usually installed directly at the ACC on fan level or on close to the high pressure pump. Or what makes cleaning even more convenient is that the system is connected to the central control room. So you just have to push the button at the central control room and the cleaning process is starting, which is quite important because I have a lot of customers where the ACC is really far away, and in big chemical plants or petrochemical plants, you have to take the bus to get to the ACC. So it's very convenient to have it in the central control room instead of going to the ACC and starting the process from the master control panel. Well, and after the cleaning of the ACC is completed, cleaning rig automatically stops, and in its parking position, it gets locked so that even cannot move anymore. And even if high winds have any influence or something, it is protected and just waiting for the next cleaning to be started whenever you want. To make it a little bit more obvious and how it works, on our website, as well as on our special page we created, it's heat-exchanger-cleaning.com. You can see a short video, short film, where you can see a fully automatic cleaning system in action. And our scope of supply, of course, includes the complete system. From customer side, you only have to provide the water and the power supply. Well, this is just a little bit the layout of and a brief, very short introduction of the function of a fully automatic system. My point is, what is the advantages? And there are three main big advantages. The one is, of course, you decrease external stuff for external stuff. You have to hire for the cleaning of your ACC or an external cleaning service. And the second strong advantage is, of course, increase of safety at work. Less people in the plant, less people on the ACC, reduce the risk of accidents and increases safety. And the third item and point is a massive increase of efficiency, flexibility, and output. That means that cleaning can be done at the real optimum point without any delay, because you do not have to organize external stuff. You have not to organize internal stuff. If you have a semi-automatic system, you just push the button and start. When you see, oh wow, I have a problem, cooling capacities is going down, and I need an optimized and highly efficient cooling process, you push the button and start. Fully automatic cleaning system allows now cleaning even during hot summer periods, where the highest cooling capacity is needed, but manual cleaning is due to high outside temperature, partially up to 90 degrees Celsius, not possible. And this is especially true in hot climate areas. And we have customers in the Middle East and also in the south of Europe. And I'm very sure you have the same problem in the hot areas in the United States, like in Texas, for example, that it is so hot you cannot clean. It is in some areas starting from March, April until October. It is so hot, nobody can work in this area. Even during night shift, it is still so hot that nobody can operate a semi-automatic system. And this is exactly the period when you need the highest cooling efficiency and you cannot clean. So the solution is definitely a fully automatic system. And an additional effect, what customer told me, is that they use it not even only for cleaning, but they spray water on the cooler with an automatic system more or less permanently. And in order to cool a little bit down the cooler, especially during the night shift, during the day shift when it's hot at noon, and they use it. And I have a customer They did it in the past. They have their own fire workers, so they mobilize the fire workers, spraying water on the cooler. And but instead of doing this, they can now use a fully automatic system. And these are the advantages, but what is the influence now in the philosophy of cleaning? I mean, traditionally, ACCs got cleaned 1 or 2 times a year. We have experience from our own cleaning services that customer calls us traditionally in spring for one-time cleaning, and then some customers looking for a second cleaning, usually in October, in autumn, or in late summer. Now the cleaning philosophy is changing to more cleaning in order to keep and run the ACC more efficient, more clean, and to gain more output. The mentioned below now on the slide is an example coming from a waste-to-energy plant in a J&W customer here in Germany, and they changed and installed a fully automatic system, and the customer reported to me that each time when the outside temperature rises above the design temperature of the ACC, he lost 4 megawatt and has to slow down his turbine, which is producing, I think it's a 15 megawatt turbine. So he's losing a lot of output when temperature is getting up. Now with a J&W cleaning system, the fully automatic one, he starts cleaning now each day when the outside temperature is higher than design temperature. And he told me that due to this effect, the perfect clean ACC, he is able to run the turbine at full speed and capacity. So he is gaining the 4 megawatt hour which he lost before. And then I asked him, okay, he didn't really share with me the sales price of the power he is selling, but he said to me, look, if I take a look on the investment cost, and it roughly took me 48 days. The payback time of the investment was really 48 days to be precise. 48 days, the outside temperature was higher than the design temperature, and these 48 days was one summer. So during one summer, it was a payback time of a fully automatic system, and I think this is a really, really short payback time. So this is our experience. 1 time, 2 times cleaning is not enough. I have even customers with a semi-automatic system. They use it 6, 7 times a year, especially during springtime when they have a lot of pollution. But of course, if you can manage it with own stuff, with own people, okay, you probably have a chance to do it with a semi-automatic system. But if you each time has to hire a cleaning service coming with equipment, assemble it, clean, disassemble it, doing it 6 times a year, or in the case like the customer with a fully automatic, doing it 48 days a year. So it's a very high cost to do it with external service or do it with own stuff. The fully automatic system with this very, very low short time of payback time of the investment is really a solution. And my recommendation is, at least everywhere where hot conditions do not allow a cleaning in summer, for me, it's very clear and obvious that you cannot run an ACC at full capacity without a fully automatic system. Even if it is a big cooler, even if it is a big investment, the payback time, it pays off. This is for sure. And even if you only have a smaller cooler, like they are typical for a waste to energy plant, for example, the investment cost compared to between fully and semi-automatic is not such a high difference, a big difference. So for those plants, I'm convinced it pays also off to clean often, to do it with a fully automatic system. And for everything in between, that means big cooler in not hot climate areas, hemispheres, okay, you have to look at it from case to case. But my experience is that even in 60 to 70% of those cases, also a fully automatic system pays off. It helps a lot to increase capacity, output, and finally profit. I just want to give one more outlook for future control of the system. But to be honest, like it is written here, the future is now, because I think in future it will not only be that you push the button from the central control room. Now there will be a fully automatic cleaning process that will be controlled by artificial intelligence, by a program that considers a lot of different parameters, production plans, maintenance plan, outside temperature, weather forecast, degree of fouling, and the system itself will give you a notice and tell the operator, now start the automatic cleaning process. And maybe it's only getting a step further. So the system is not asking the operator to start the process of cleaning. No, the computer will start the process on its own, and the operator will only stop it if there is something the computer cannot consider or cannot take under consideration. And those systems we can also deliver right now. We have a close relationship with a university close to Bochum, with a university in Dortmund, and we are developing with them such artificial intelligence programs. And well, the future is now, and it already started. Just one maybe final thing before you maybe have some questions, which will I be happy to answer, is even if you can start with your fully automatic system due to our technology step by step. So we developed it in a module system. So if you can say, okay, budgets are tight, we cannot start with it from like this and invest into it completely. You can do it in as your budgets allow. You can do it step by step, and so you can get your fully automatic system over a period which fits to your budgets. Well, and this finally is our strongest argument, before and after. It's a clean cooler, efficient, running with full capacity, and allows a high output of your plant. And well, I think this is our references all over the world. Our cleaning systems are used, and this is our organization with our own subsidiaries in the world, and of course in the US with our very good partner and friends from Concord. Thank you very much.
Thank you, Aaron. That was
listening.
It was a really good presentation, really informative. I know cleaning is an important part of the puzzle when it comes to ACC performance. And then originally plans were not typically built with an automatic system. So kind of realize it's, the manual system is really labor intensive, and it's probably worth investing in an automatic system if, plants are required to clean regularly, almost annually. And with the automatic system, I think the frequency of the cleaning could be a lot more. So definitely worth the investment. There's a bunch of questions. Andy, did you want to unmute yourself and ask on those questions? Looks like you have
Let me
3
see.
questions.
Just getting back. I have to change. Is it? No. The view. Currently, I cannot see anything. No,
Yeah, Andy can go ahead and ask his questions directly.
yeah, please.
We can't hear you, Andy.
Yeah, you got to unmute, Andy.
Sorry.
How's that? Am I back?
Yeah, much better. Yeah, we can hear you now.
All right. First question, if there's enough supply water, can multiple rows be cleaned simultaneously?
I have to make it a little bit louder, sorry. Can you repeat it? Excuse me.
Yes. If there's enough supply water, can multiple rows be cleaned simultaneously?
Yeah. Oh, yes, of course. So ACC, single rows, multi-rows, multi-layer. It is not a problem for our technology.
Okay. The second question is the practice I'm familiar with is people turn off the fan in the cell that's being cleaned. Is that done? Is that managed by the cleaning system? Will it control that, or does operations need to do that manually?
No, this has to be done manually. If you run it from the ACC, from the master control panel, then you have to switch off the whole ACC if possible. Usually it's not possible, only during shutdowns. But if you do it during usual production processes, just one section has to be shut down in, let's say, if you want to have an optimized cleaning. But if you clean it regularly, like in the example, 48 days when it's getting hot, this customer is running the ACC, stopping no fans, and doing the cleaning in parallel. So it's, if you have a cleaning service, I would not recommend it if you do it once or twice a year only, but in an optimized process with fully automatic, you can run the fans.
Okay, yeah, I can see that. I would be concerned about some of the debris being returned if it wasn't off, but if it's clean, pretty clean, that's reasonable. I guess I'll ask my other one, Rishi. Can you adjust the spray flow rate automatically? You probably wouldn't want full flow if you're just using it for cooling.
I'm not sure if I got your question right, but
so
we have a
when you're running full flow, normal spray pressure, there's a lot of water, a lot more than you need for evaporative support. If you were just trying to use it for cooling, can you run it at a much lower flow rate to do that?
Yeah, you have different speeds. You can run it faster. You can select and the program. If you just run it up and down, you can have a program where the nozzle beam is going up and down, and then the chassis moves up, down, the chassis moves. So you have a selection of different programs, which also, let's say, is a difference in intensity of cleaning. It depends, but if it's really clean, you can run it at high speed and with less water consumption.
Okay, all right, that's fine.
And one other thing, maybe we're working a lot on developing systems to reduce water consumption. I know in the past, a standard was with 170 liter per minute. We are now using for a single row ACC maximum 100 liter per minute, and we are currently doing tests in our workshop, and I'm very confident that we can reduce water consumption again for a single row ACC down to 70 liter. So it's a massive reduction of water to save resources, and as well with a smaller pump, we have less smaller motors, less energy consumption. So we are doing a lot of research in this respect.
There's a couple of questions from Shaheen. He's asking whether there's a limitation on the temperature of the tube bundle surface for starting the cleaning, and also what is the water quality for the cleaning process?
Temperature, no, there's no limitation. So it should not be as cold, so it should not freeze. So, but if it is hot, we are running it at 90 degrees Celsius. So I don't see any limitation in temperatures. And you mean the quality of the water, or what was the question?
Yeah, the quality of the water, I'm assuming has to be Demon water, right?
No, just regular industrial water. No demi water is necessary.
Okay.
I would say, Arndt, with normal spray and misting systems for cooling, Demon water is recommended. And if we were doing this 6 or 7 or 8 times a year, and especially if we're trying to use it for cooling, that would have to be evaluated at least, whether it's good to spray water with some minerals. I know it's not bad quality water, but still it's going to build up if we use it more than a couple times a year.
Well, if you have demi water, if you like to use it, of course, it has advantages for sure. We all know them, and but on the other hand, our system is made to use regular industrial water, and until today, I have no customer who is using our systems and having problems with lime and or something like that due to the use of industrial water. So.
Okay. Mike is asking, if you're cleaning an ACC on a high temperature day, is the fan in service when cleaning? If so, what prevents the foulings from being blown back up into the tube bundle by the fan?
Yeah, of course. If you run it by run the fan in clay, you are running it against the wind, let's say, against the process, and it's pushed back, but not completely and not fully. You have a positive effect. We know it from customers, also from the service, because a lot of customers say, look, I cannot stop the fans. I cannot. Production does not allow it, but I want you to clean because it's even better than not cleaning. It's not optimized, but this is on a process which is done 1 or 2 times a year. Now we are talking about a high frequency of cleaning. I can tell you from this example, from this waste to energy plant in Germany, if you are there and it starts cleaning, it looks clean. It looks clean, really clean. But he said, I still have a positive effect and can run the turbine at full capacity. So I would not be afraid to run the cleaning system even with fans on.
Okay. Chris Samuelson is asking, how are long high pressure water hoses managed as the system moves back and forth?
Oh, this is a special hose and it's a special cable. They are guided in what we call an energy chain. This is a chain you probably well known also in robot used in an automobile industry. So they are designed to move much faster from left and right and back and forwards, let's say. So our speed and our process of it is very slow compared to this. And So it's guided into these energy chains, and cables and hoses, as I said, are especially designed for this kind of energy chains to be guided inside.
Okay. David is asking, how does the control room know the system is running or where it is in the process? And if something goes wrong, is there a notification?
Yeah, there's a lot of safety devices in it. So, of course, it's a matter of your authorities and how it must be done. It's from country to country a little bit different, but you have, of course, a message in the control room that the cleaning process is running. And you can also, if you like, visualize it, where the cleaning system is positioned. And you also have warning and lights at the ACC itself that there is a machine in progress and running, so that nobody is running into the machine while it is working, let's say. But as I said, it's not a high-speed running machine. So any kind of accident due to this is quite limited. But we have a lot of safety devices also on the equipment itself, so that if there is any kind of problem that it keeps not running and probably destroys himself, it's sensor controlled, and if there's a problem, it will stop automatically, and you get a message into the control room that there is an issue and somebody has to go to the system, has to go to the ACC and take a look at it.
Okay. Jeff has a question. If the ACC is off and cool, does the water quality make a difference?
Yes, the ACC is off and cool. Does the water quality? I have no information about this. I cannot imagine. No, I have no
So
information.
that would suggest that the water is drying out quickly on the fins if it's hot, and not drying so much if it's cool. So that, yes, that probably would be a better situation.
Yeah, but anyhow, we run it with high pressure. I mean, it's still on a single layer, it's 50 bars. If it is a multi-layer, we run it 80 bars. Sometimes in service, we run it up to 100 bars, you know. So we do not have a lot of water on the cooler,
Yeah,
which remains in the cooler.
My question was related to if there's a tendency of scaling. If it was like hard water, if the surface was hot, you'd have more of a scaling problem than if like in an outage situation when the ACC was offline and cool. I would think that's probably the most ideal situation for your system to be used.
Sorry, was that a question to me?
No, I think Jeff is saying if the quality of water isn't that great, so say it's hard water with say like a higher conductivity, with the surfaces being cool with that hard water, isn't it better when it's off, like during an outage, to clean during an outage rather than cleaning it, say when it's online, when the surface is, hotter, because the tendency of the water scaling up would be more when you're online versus when you're off.
I have no feedback from a customer that is saying he has an advantage that it is done during a shutdown compared to online cleaning.
Okay.
Thank you.
One more question is, why can't we clean the tube bundles before the summer using the semi-automatic cleaning system? And why do we need to clean it daily during summer?
So it depends on your cooling capacities. I mean, a lot of customers I know have a problem because outside temperature has a high influence on the ACC and the cooling capacities. And if you have a ACC with a very high design temperature, and even if you have a big cooler or you are not running the plant at full capacity, so you do not need the complete cooling capacity, then of course, cleaning and such a high efficient cooler is not an issue for you. But to have a cooler in an area where it's very hot, for example, I have examples from the Middle East, and the example, I mean, from the waste to energy plant is not in a very hot hemisphere. It's Germany. Okay, it can get very hot, but not like in the Middle East on a long-term basis. The other problem is that the design temperature is 25 degrees, and they can not run the turbine and the capacity fully when the cooling capacity is going down if outside temperature is getting higher than the design temperature. And I know from customers also in Middle East region, and we are now currently in discussion with a customer there, and he already made a calculation that he will lose output of a big waste to energy plant. He will lose 1% complete output of the plant. If you calculate a price for 1% of the total capacity of your plant, in a chemical plant, your product, 1%, or even there, I have examples where they lose 5% of output, and they know that they can only gain it with a cleaning system and a clean ACC during summertime. Well, they save millions with a fully automatic system, millions of euros or dollars. With this investment, it really pays off.
Okay. One more question that I had was, what about when you clean it, the drain water, the wastewater? Do you have customers that have restrictions on whether that wastewater has to be collected and recycled? Because I know at our facility, we're not allowed to dump water on the ground. So have you run into those kind of issues with your customers?
Yeah, I know this issue. It's very seldom that the water cannot be, or that the sewage system cannot use for this water. It's very seldom that it cannot use. We have customers where we have the duty to collect the water, yes. But to be honest, we cannot collect 100% of the water. This is not 100%. We can maybe collect 70 to 80% in best case. But yeah, I know those cases, but they are not that often. If I take a look on the inquiries and the systems, the 420 systems we delivered worldwide, so it's not a case that happen very often. But I know those cases, yeah.
How do you collect that water? Is it just temporary like tarps or?
That's it. Yeah.
Okay. Yeah, that was Bob had a question. Cleaning to maintain output is a good goal, but do any customers have water use restrictions?
I've not met such a customer, to be honest. I know that water is tight, let's say, and we all want to save water, and we do it. And but even if we clean 48 days a year, or 6 times, 10 times, the water consumption, if you compare it to the usual complete water consumption of a big plant, is not increasing the whole consumption of water of a plant significantly. But as I said, we are working on this, and this is an important issue. And well, coming down from 100 liter per minute down to 70 liter, which is now, I think, what we can reach very quickly in future, is another saving of 30%. So we are working on this issue a lot.
Okay. Chris Samuelson says that you have water use restrictions in California. Chris, you want to elaborate on that and how you go about doing that?
Sure. We do have annual water use limits at both of our sites in Southern California. It's around 120 acre-feet per year, and yeah, it's challenging. It's challenging to meet that even without considering cleaning for ACC. So it's definitely a concern for us.
Oh, okay. And then
But
what
we
was
have,
the kind of,
but we have semi-automatic systems running in California.
Sorry, what was
But
that?
we have semi-automatic systems running in California.
Yep. Yeah, we have your semi-automatic
Yep.
cleaning systems on both of our sites in
Mm.
Long Beach and Huntington Beach.
Yep.
and then how often do you clean your ACCs, Chris?
Well, the units have only been operational for less than 2 years. To be honest, I think they've only cleaned once,
Okay. Okay.
but we
Bob,
probably need to clean more than that.
yeah, Bob's asking whether Nevada has, or at least my site doesn't really have water use restrictions because we have our own well. So we pull water out of the aquifer, and we own the well, right? So NV Energy doesn't really have water use restrictions. So it looks like that was the last of the questions. Thanks a lot for the presentation and answering all our questions, Arne. Appreciate it. The next presentation is going to be by Andy Howell. He's going to talk about the technical guidelines for ACCUG. Go ahead, Andy, if you want to pull up your presentation.
Okay, I'm trying to make it full size on my screen. Let me see.
If you just go to slideshow menu up at the top and then start from beginning.
Slideshow menu.
Where that the icon all the way at the top in orange that has the little play button and the screen next to it.
Okay, let me try this. Are you showing a full screen there or not?
No. If you click the stop sharing.
Okay.
Okay, then just share your screen with the PowerPoint on it.
Okay, when I select that, it goes too small.
So right down at the bottom where the little minus sign is for the zoom. At the very
I'm
bottom.
not. Oh, here.
And then click on the little screen that makes it the slideshow right next to it. That one.
All right. Okay.
All good.
Thanks. All right. All right. So we have some guidelines documents. I think many of you know this. We've developed through the group. We're trying to make these as useful as possible. I'm going to go through them. Some of you are pretty familiar with them. Some of you probably have never heard of them if you're new, since we have a expanded audience here. So I thought I would take the opportunity to go through each of these 3 documents and talk about them. First of all, I wanted to mention about the group itself. This group was probably like all technical groups, started as a grassroots organization. In about 2007, we started talking about increasing technical change among interested persons with air-cooled condensers, speaking mainly from a user perspective. And in 2009, the first annual meeting was held. NV Energy actually got that rolling, and I helped some with that. And so I have a list here of the places we've gone with the meetings, and Las Vegas, San Francisco, Pueblo, Gillette, Summerlin, Nevada, which is a surrogate for Las Vegas, San Diego, Gettysburg, Dallas. The meeting in Xi'an, China was not really officially from the group, but we had a lot of group support. Then back to Las Vegas and Colorado Springs and Querétaro, Mexico. So we, looking at these makes me feel nostalgic when we used to actually get together, and also makes me look forward to next year when we will presumably be getting together in person. The annual meetings involve presentations and discussion, pretty much just like this virtual meeting. We always had an ACC site visit. I don't remember if we did that in 2009, but every meeting since then we have for sure tried to locate the meeting near an ACC with something of interest. In Pueblo is Xcel Energy's hybrid cooling system. It's the largest parallel cooling system in the world, unless something's changed in the other places we've had. Like in Dallas, we visited Midlothian plant where they are doing a spray misting, and we've tried to find items of interest in each visit as well. But that's connect each meeting, and it's been a very popular thing. Most of the attendees stay an extra morning and attend plant tour, ACC tour. We involve user operators, OEMs, vendors, and consultants. We don't have people shut out from the meeting. We do sometimes charge certain people more than others, but for participating, but we want input from everyone, and some of these everyone in these groups has expertise that's valuable. The website was developed, I don't remember exactly when that got going, but Combined Cycle Journal has been a huge help with that, and SV Events has, Sheila helps with that as well, and this is the website. If you're not familiar, you're probably familiar with that if you registered, since that's where it took place. We have an email forum, which many of you are familiar with, has not been used real actively, but it's always available, and there's a lot of potential for people to ask their questions and get answers. Also on the website, we have presentations from past meetings, nearly all of them. I try to request that people at least revise and submit a presentation suitable for posting if there's anything confidential you don't want in that. But so we have lots of presentations on the relevant ACC topics. Then of course there's registration information for current meetings and other technical information. We have not really loaded that up near as much as we could, but we can put technical information on the website, and we do have a little bit, and so that's could be a useful thing as well. The technical guidance documents, which are also can be found on the website, include a steam side inspection document issued in 2015, fin tube cleaning in 2018, and air and leakage, which hopefully we'll have a 2021. That would be keep consistent with our 3-year cycle, and it's in progress. And essentially, I just need to organize the comments I've had and then send it out again for any further comments or review at this point. So these are the 3 technical guidance documents labeled 01, 02, and 03. And we did put a revision date on these, which we're not keeping up very well with, but hopefully I intend to get that out and talk about some revisions. Okay, first document was the internal ACC inspection guidelines. So our objective with this was to provide guidance to ensure a comprehensive inspection. And this originated largely because those of us who are doing inspections just felt it would be useful to make sure we don't miss things and get input from others to develop a document that would show that. Also provides a focal point for the ACC community to optimize these. So we can talk about it. We can comment on the guidelines and any corrections or changes or additions that people have experienced. And we also are using a quantifiable index to allow a comparison between ACCs in terms of corrosion and potentially chemistry as well. This originated as corrosion and chemistry related inspection, because that was where some of us interested were looking at, but it should ideally include the entire internal ACC, or anything else that might be of interest. So that should take place. We got input on this document from ACC user operators, consultants, and OEMs. And the product that we have has technical information and examples. It has an itemized inspection worksheet and corrosion index, the dossier that very duly mentioned on Tuesday. So we have in the document an introduction. We know the ACCs are large with lots of iron, and the corrosion that takes place there results in iron transport and potentially air leakage. And air leakage causes major challenges. All you need to do is, we'll talk about air leakage a little later, but all you need to do is think of the fact that a typical sized, mid-sized ACC, large ACC may have 20,000 fin tubes, and counting the top and bottom, that's 40,000 welds, and we all know welds have their potential for susceptibility to leaking. So there's a lot of challenges when you're talking about looking for air and leakage. And so you get a leak, like was mentioned a little bit ago with some pinhole leaks by James, that finding those in the large number of tubes, where they are and what can be done about them is a big challenge. If it's causing a lot of air and leakage, that's a big performance concern as well as a potential chemistry concern. And then the effectiveness of steam cycle chemistry can be confirmed by internal inspection. So if you do an inspection every year, every other year, any kind of a routine, you can see how changes in the steam cycle chemistry have changed what you see in the inspection. Now, we understand you may want quicker information than that, and iron monitoring for corrosion is a good option for that. But ultimately, what's actually going on inside the system is what we consider the final arbitrator of that. So the document contains these things. You can just look at the document and read through those. I won't read them. But we tried to include items of all the areas that need to be considered, and of course, any suggestions for additions are welcome. In terms of plant configuration, there's a difference in how plants, how air-cooled condensers are damaged by corrosion. Once-through boiler is a system where no contamination is allowed. There's likely to be almost certainly going to be a condensate polisher, and a filter is likely. High pH limits the polisher effectiveness, so it's fine to run. I think we heard that running it in a polisher and ammonia cycle, especially a deep bed polisher, is ideal. But still, if you have ammonia cycle polisher and you're running at a pH of 10, it's not going to retain contaminants very well. So the high pH limits polisher effectiveness. So this is a challenge. It's not too many plants are in this mode. There's maybe a couple in the U.S., a few in Australia, and a large number in China, and then the ones in South Africa. Those are mainly where once-through boilers are run with air-cooled condensers and have full flow polishers. The heat recovery steam generators and drum boilers are better at removing contaminants because of the boiler kind of collects those and you can blow down. Then another comment on the heat recovery steam generators is using amines is considered more acceptable in these than in once through boilers. At least that's the understanding that I've had in the past, is that the amines can cause damage to polisher resin, and that's been a concern. So factors that influence the internal corrosion can be the support structures. So we'll show pictures like the one we showed yesterday of the how those support structures and cause turbulence and can experience corrosion. And cooling tube length and the entry shape. So when the steam is headed into those heat transfer tubes, into the fin tubes, it has to make a 90-degree turn. If there's a little ridge on the weld, that just further adds to the turbulence and may accelerate the corrosion at that point. Number of rows and isolation of risers, how well balanced the flow is and all that. The fans and operational flexibility, condensate drainage, and the deaerator. I think the system where a lot of the condensate is collected has deaeration in many cases. Parallel cooling, steam velocity. So for instance, the plant XL had in Colorado, which I was actively involved with, had a parallel cooling, and depending on the temperatures and the cooling, the steam velocity had a potential to vary, and that because the corrosion that takes place in the air-cooled condensers is a form of flow accelerated corrosion. Velocity is a significant component. Operation, it's been demonstrated. I think Barry showed a slide that how higher pH reduces iron transport. There's a direct correlation. Neutralizing filming amines generally reduce corrosion better than ammonia. I think for many of you are aware, but as the steam condenses, ammonia remains in the vapor phase more so than amines. Amines will condense with the first condensing condensate, and so they'll keep the pH up in that early condensate, but ammonia will tend to not join the condensate until it's started down the tubes for some distance. So the pH remains a little lower if you're using ammonia. And then, of course, historical data on these things: chemistry, control, iron transport, unit operation. If you're making changes, it's really good to have background iron transport data, to have been monitoring the iron, collecting data, and knowing what it is routinely, so you'll know when you make changes what's going on. Unit operation is very significant, but often we don't understand exactly why. Sometimes things change and we don't have an explanation, and it has to do with operation if we in the chemistry group are not paying attention or aware of those things. So this is another example of how we need to tie the groups together and work together and know when there's changes that might influence the flow rate or ultimately the corrosion. And then the condition of the ACC offline, it's important, but it's really hard to know what to do. You're not going to flood a air-cooled condenser with nitrogen. It would just take too much. But getting it opened and dried might be a good way to resolve things if you're going to be offline for a while. The frequency of inspection should be looked at thoroughly during construction. We were constructing the Comanche Unit 3 ACC, and I looked at it regularly and saw lots of interesting things like this. This was in one of the upper ducts, just piles of garbage. And it had not been, to be somewhat fair, it had not been cleaned out yet, but just shows that there's a lot of stuff there, and you need to look and make sure it gets cleaned out. Don't just be taking for granted that that's obviously something they'll clean out. On the right side of this, in this condensate header collector, is a row of chips and debris of another sort. Again, another thing that needs to be, you need to make sure that your contractors are cleaning those things out. So look at it frequently during construction, within a few months after commissioning, if possible. The first check we had on the unit I was working with was about 14 months, I believe. But whenever you can. This is an example of a plant where 5 or 6 months after commissioning, they did an inspection, and wherever you see the bare metal crossbars or on any of the surfaces, it's a sign that there's some kind of corrosion going on. It's you see most of the surface is covered with a reddish or dark oxide layer, but wherever there's shiny areas, it's essentially shiny or white areas. It's essentially something showing that material is missing and has been removed. And then we advise in the document to try to do an annual inspection, and also to try to look at one duct for repeat examination and maybe rotate the others. If you have a lot, the unit I worked with had nine ducts, but if you don't see any problems after a few years, nothing seems to be changing, and you're not making any other changes in operation or chemistry, you could probably change inspection to a less frequent schedule. What you don't really want to do is have never inspected it, or look at it once and assume that it doesn't change. Okay, another section discussed in the document, an important issue is safety. Falling is obviously the first thing you think of. You're way up high, needs appropriate railing, walkways, and elevators. This is an example of a challenging location. The entry manway is on the top, and you can see there's a nice ladder there, so you can basically be upside down while you're climbing to the top, or you can get dropped from a man lift. Either way, it's not an ideal scenario for doing an inspection. And then another picture. These are way up in the air, 30 feet, 10, 15 meters. So it's something you don't want to be falling for any reason on. The upper distribution ducts, best way to inspect those is to have permanent ladders and platforms in place. This is a unit that you can see has essentially ladders at each of the ducts, and then there's a platform at the top and entry to the duct right there. Now, I originally thought this was a excellent planning ahead for inspection, but actually I think it was really meant for inspecting valves up in that area or something. So it happened to be a perfect setup for looking at doing internal inspections as well. And again, here's a scaffolded system up to the duct, up to the opening for the upper duct to go in for the inspection. This problem with this scaffolding is, of course, you gotta ask for it anytime you want it. It's got to be paid for. You got to have it in the budget. You got to argue for funds that may be limited. So having to scaffold and go in, it works, but unless the plant is really committed to it consistently, it's hard to get consistent and repeated inspections. Ensure adequate air inside ducts. I looked in one upper duct of a certain ACC, and as soon as we started to go in, there was a strong smell of ammonia, so we did a test on it, and it was above the permissible limit. Ammonia, if it's used in the system, needs to be aired out before you can go in. So we need to make sure that there's not an issue with the breathing space there. Lighting, it's good to have some lights that are adequate. Just flashlights is kind of limited for doing an inspection. Floor drain ports. I haven't seen this a lot, but one of the ACCs I looked in at the main duct had a large, I guess it was a condensate collection area. I don't know. There was a large drain port that was like, I don't know, 8 foot diameter, and you sort of had to walk on a little bit of a slope to get around it. So that was not ideal. But being aware of that, and then planning for removal of personnel during injury. There's only one entry typically to these upper ducts, and if you're 50 feet down the duct and need to be getting out quick for any reason, that's not going to be an easy process. It's not really a cramped and tight space, but it is sometimes a little bit challenging to walk around crossbars and over stuff. So some kind of a plan, at least be prepared if someone has to be removed. Have enough people to help, have a rope or some equipment to help. Okay, during the inspection, the thing to do is record both normal and abnormal surfaces. The tendency is just to take picture of things that look abnormal, but be sure you take some of the normal stuff as well. Anything that looks like shiny metal or white areas, different colors of iron oxide, not always sure what that implies, but it's good to have it documented. And then deposition, sometimes there will be piles of deposits in certain areas, and it's good to both take pictures of those and collect those. Now, this is the rating system, the DASI, which is Dooley Howell Air Cooled Condenser Corrosion Index. And ratings on this is 1 to 5, and see the upper section for the cooling tube entries. We separate this from the lower section. The upper section is critical because it's the entry to the tubes. Everywhere in the entire ACC has a fairly thick wall, relatively thick. It's not likely to corrode through in any normal scenario. The tubes, the heat exchange tubes, the fin tubes, have wall thicknesses that are much smaller than that, and they do have a potential to corrode through this. 0.59 inches. I forget if that's a millimeter, but it's pretty thin in that area. So it's an area that we separate, and really it's a more critical area. It's also the area where if iron oxide is released by corrosion processes, it will travel into the condensate. Not really sure in the main duct, besides there being very little surface area, relatively little. Not really sure where those particles go. They may travel with the steam, but there's not going to be near as much as what the potential is in the upper duct. So good conditions, no corrosion found, something like this. Nothing shiny metal. Everything's got some kind of a dark oxide covering it. Looks pretty good. Looking down into the tubes, right at the top area where you would see the corrosion, there's no bare metal. Second one is minor corrosion. There may be no bare metal, but these black deposits at the tube entries are significant. You see these deposits, these black deposits, they seem to be material that has been, it's a result of corrosion in the vicinity. So the corrosion takes place, the black material deposits, and there's some corrosion going on underneath that black material or adjacent to it. There's some metal loss that's taken place, and it's not bad because it's not bare metal. It's not showing that, but it does tell you that there's give it a rating of 2 because there's something going on. 3 is moderate corrosion, scattered spots of bare metal, black deposits. So this, I think we rated this a 3. It's not a large area, but you can see that there's definitely shiny metal areas. There's a lot of the black deposit. It's definitely not a comfortable scenario to have a lot of this bare metal showing. And you can see it's going mostly a little down from the weld, under the weld. So there's something going on where the turbulence takes place right under the weld. Now the steam is going forward. The surfaces that have bare metal virtually always in an air-cooled condenser have something to do with a perpendicular face to steam flow. You see a little bit where there's other areas, like in the middle of this a ridge in here, you can see a little metal loss. It's not necessarily perpendicular, but it is beneath a support structure. This is not showing that, but it's beneath a support structure. So there is flow going down as well as forward. If we looked at the tubes from the other direction, you would see nothing. There's no corrosion where there's not a a significant flow component. Okay, so this was the same area, one of the similar areas, showing the again, the flow is going towards these support structures, the cross structures, and underneath them, where you see the black material, shows that there's definitely something going on that's accelerated by the turbulence generated by steam impacting these cross structures and going down with high turbulence. Number 4, more serious corrosion. So this is just kind of a judgment. Widespread bare metal at tube entries and widespread black deposits is just a example of a lot of bare metal in this region, and so it's a little bit of a judgment call on whether you're rating it 3 or 4, but this is definitely more widespread than the previous one. And then serious corrosion is basically a hole in the tube or weld. So this is an example. It's hard to see in the shadow, but there's a hole through this tube, and then you'd expect to see some widespread corrosion elsewhere. One of the things the index is not fully defined on is how many. If you find one hole in one tube in one upper duct, that doesn't sound like the entire ACC is doing poorly, but at any rate, that's in this scenario, that's what we're calling it. And this is another one with a hole. The hole is just over to the right underneath the weld. You can see a little bit of the black oxide that was there. It's been mostly lost. Okay, then going to the lower section, turbine exhaust, the lower duct, and the risers are all included in this section. An A is good condition, basically no corrosion found. So you see this stuff, kind of dark oxides on the metal, but no real issues with corrosion showing. Minor corrosion, scattered spots of bare metal. So this is going into a riser duct. You can see some of the welds that basically they're facing the flow. Get a little bit of have a little bit of metal loss, and then inside the riser duct as well, there's a little bit. So we call that a B. And then more serious corrosion is just more widespread. Again, going to a riser duct. It's pretty common for these bars, the support bars, throughout this lower section of the ACC to have some significant metal loss. But at any rate, we rate it because it has to do with the corrosivity of the environment, as well as the fact that there's probably some iron particles joining the steam flow in this scenario. Okay, so the dossier is used to compare between units or to track changes within an individual unit. So it's an easy way for us to interact with other people and rate something that we haven't seen. So it's useful, and I'd encourage people to use that. And I will tell you that anytime you want to send me pictures and ask me what I think an appropriate rating is, I would be very, very glad to do that. Just just to help myself learn as well as communicate on that. This is the inspection worksheet, and it just lists some background information to collect and some locations. This typical information you'd want if you were looking at primarily corrosion issues. Then I mentioned non-corrosion components. Integrity is also useful and should be considered. We would love to expand on this topic if we have more information. This right here is a crack adjacent to a weld going into a turning vane at the end of a lower duct. Okay, moving into the next one, the ACC fin tube cleaning guidelines. Again, the objectives: provide guidance for important issues in fin tube cleanings, provide an expandable document so that we can add input from various people's experiences and needs, and provide a basis for considering options for fin tube cleaning systems. We heard about a really nice automated system just before, and that may be good, may be out of your budget. Some systems are fin tube cleaning systems are much better and more thorough than others. So at least have a basis for what you're looking at with those, and then to identify the effects of blocked fins on cooling system performance. So the fins can easily be clogged, and you lose cooling capacity. Got input from the relevant people, and the product has technical information, examples, and issues to consider. It's just the contents of the document, things you would expect to have in there. I'll go over a few of these following here. Looking at those fins on those tubes, those are really small, really tight. That gives a lot of surface area for cooling, and we need that for air cooling, but also makes it very easy for clogging when pretty small bits of debris can get in there. This was just showing for anyone who hasn't seen the inside of a upper duct, the opposite side. So this is on the left is the fin tube. As we see it on the right is how we see it from the outside. Then if you're inside, you see it the typical size. There are some other sizes, other shapes, but the 3/4 by 8 inch tube is the single row that's dominant in the construction these days. The fans, so we know the fans are blowing air up, a lot of air, and pick up whatever's in there. If you've stood under an ACC, like most of you probably have, you feel the airflow coming from whatever direction is available, and a lot of air moving. Fans blowing this debris up, it collects on the fins. When you see something like this, it probably means you haven't cleaned for a while. Over on the left, you can see some pretty thick patches, and a close-up on the right shows that there's really not much going through those. You can usually see a pattern. You can tell where the air is blowing in the fan bays. If you look on the left, you can see there's areas that are heavily fouled and areas that are not, and that's basically the pattern of where the airflow is primarily traveling. Of course, when it gets blocked, then the airflow moves to another location to take advantage of all that. And again, here on the left, you see even looks like a paper towel or something that's collected in there, and things like cottonwood seeds, any kind of vegetation that can be picked up. Dust is real common. We heard a little bit from Hub about the oil spattering, and this is fairly common. The unit I was working with had about half the fan bays had oil spatter in them at one time. Not really sure the significance of this. My initial thought was this is a really bad thing to get on your fin tubes. It will collect debris and be hard to remove. May need some special solvents, but not sure that's really whether that's really the case. It does seem to kind of degrade over time. Okay, so here's a person doing a cleaning. In this case, there's one person operating the system, and this is a semi-automatic. So he'll pull the ladder along to the next area, but he won't have to run the nozzles up and down. They're automated in that respect. And here's a system operating in a pretty strong flow. It does a really good job of cleaning. Of course, you clean it from the outside in, since the contamination comes from the inside out. You could, whatever it takes to clean it, maybe 2 passes up and down, or once up and down. May do a slower flow rate. These things are typically adjustable.
Hey, Andy, there's a couple of questions since you're on that topic.
Okay, all right.
Mohammed Wager, do you want to unmute yourself and ask Andy that question about the gap in the tube bundles? So he had a question about.
Yes, I have a question about it.
Okay.
Go ahead.
Hello again, Mr. Howell.
Yes.
Thanks for presentation. Okay, let me. Okay. I have a question related to gap. Is there any allowed range to extend the gap in the whole ACC? I want to know the percentage of the range, if there is any.
Okay, what are you meaning by gap?
Between two bundle, you put
Oh,
it.
okay. Yeah. So I have some pictures, but I don't have them on this presentation. I could send you that. The gaps can be a big issue. I've seen gaps that were as much as maybe half an inch, and if the unit's running, you can feel the airflow blowing right through the gap at a high rate. It's obviously bypassing the fins, and you're losing some of the efficiency. I don't know how significant that is, but I did see in China where they put together they put their units together one tube at a time, and rather than in bundles, and every section seemed to have a gap, and they put some kind of a rubber. It was almost like a windshield wiper on a car, some kind of a rubber piece they put into those gaps. Some of them stayed in and some of them didn't. But yeah, I recognize that's a problem. I'm not sure how installation deals with it, but there probably are ways to block it if you feel it's worth the effort.
Okay. Thanks, Mr. Haber. We have always have a question: what acceptable range of this gap? And we always answer to operators to check the characteristic curve of ACC. If it's not working well, is the performance curve of if performance of ACC is not working well. Okay, you have to put rubber or and use water, another solution to put gap.
Right. Yep, that sounds like what you do. If it's bad enough, you plug it.
Okay, thank you, Mr. Haber.
Sure.
There was one more question. Does anyone use a foam product with water to remove oil, etc., or is it just straight up surface water for cleaning?
Yeah, anyone who wants to comment is fine. I know we were looking at that. We were talking with one of the commercial cleaners about that, and there's always a concern about what gets on the ground and whether it's appropriate for that. I did notice though, after a few years, the regular cleaning seemed to be removing some of the oil. So it seemed like it was breaking down, maybe with the dust and particles joining it, but it didn't seem like it was a permanent long-term residue. But
Okay.
it is a concern, yeah.
Good. Do any of the other users have experience using a foam product? Or, if not, there's a question from Bob. He's asking, is there any work going on that you know of with regard to the use of grit in cleaning system in place of water? The thought that in an arid area with high temperatures in the summer that you can continue to wash daily seems illogical in the days of climate change.
Grit, I'm not sure. You can look at these fins in front of you and try to think about how what the grit's going to do, how much of it's going to get stuck in there versus making it through. We're looking at the face of it. It goes back 8 inches approximately, and I don't know. I'd be a little reluctant to put anything that had any size. A really fine material, carbon dioxide dry ice is not a bad idea because it'll be gone. but I'm not certain how effective dry ice is, or how expensive. This is a big structure. How much dry ice you'd need to clean the whole thing.
One of the other questions is, how can we remove fins at the base of the tube where the corrosion starts? Is there a special tool?
So this question is suggesting that there's corrosion in the tube, or are we talking about the top?
I think it's the base of the tube. I think where it comes in. Sean, do you want to chime in? You can unmute yourself and ask that question.
Last one, contracted services, like basically you may support people in operations to deal with the major tasks like isolations for steam turbine cycle, HRSGs, HPLs, water pumps. Again, we have
Hey Sean, could you we can't barely hear you. Could you get your mic close to your mouth and not speak directly into it?
right? So farming, unfortunately, we have one into a negative variance, 1,000 and something dollars.
My connection is very bad.
And my proposal was to increase the line from the 5,000 to 10,000. I mean, if that seems to be too much.
Okay, I think we lost them.
Maybe we can try that in the after session if we get that far, and see if he can either write something a little more explanation, or maybe we can understand.
Okay.
Is there anything else right now?
There was one more question about the cleaning. What oil removal product can be used that fouls up the fins, clogging the fins with dust, oil, and dead insects? I think Andy said just water, right? Spending your
The
experience.
water, the pressure is good. The pressure removes those things. Dust is easy. The oil is a little questionable. Bugs are easy. Those things come off with water.
Okay. And then one more question is, bare metal is the indicator of corrosion or rusted metal? I guess going back to the chemistry portion.
So rusted metal is indication of corrosion that happened and left the rust in place. Bare metal is usually indicating that the corrosion is ongoing and active because the rust has been removed and exposed fresh surface.
Okay, I guess that answers it. Yeah, you go ahead with the presentation, Andy. That was the last of the questions.
Okay. All right. Yeah, and I just threw this picture just as a. This is actually hail damage, but I thought it made a good example of what would happen also if you over pressurize the water. There are limits to how strongly these aluminum fins will hold up, and you don't want this, because once you get this in a situation, you can see that quite a few of these fins are not really going to pass air through very easily, and you basically lost some capacity. So you want to make sure you're not over pressurizing the water spray for cleaning. This is on the inside again, seeing, if you look on the left of those tubes, you can see that the bundle looks quite a bit cleaner. And this is typical. It's not hard to get things clean if they're lined up right and you have a good system. We covered our gearboxes, and motors, tried to keep them from getting wet. They're supposed to be pretty water resistant, but just to ensure that wasn't an issue. I guess I understood there were some desiccators in those, the oil systems, that sometimes can get wet as well. Underneath, this is one reason, Jeff, you might not want to be cleaning when you're offline, just because you can't be doing any work under the ACC while that cleaning is going on. A lot of water can accumulate. There may be environmental issues. I know there's a couple of states where the ACC users are required to collect the water and dispose of it and not let it soak into the ground. And I wouldn't be surprised if that becomes an ongoing increasing issue. And then also there are maybe concerns about the equipment under there. Just make sure it's waterproof if it's getting rained on. This is an example of what might happen if your water is not high quality. That was what this corrosion was attributed to at the bottom of these tubes. And I don't remember the exact issues with the quality, but it was demineralized water won't do this, but it's very expensive to use a large volume of it, and pretty much everyone uses something typical tap water quality, which is not bad, but again, just a concern if you do get corrosive water, you can have problems. In conclusion of this document, the guidelines intended. Oh, this is internal inspection. I didn't change it, but anyway, the guidelines of both these are intended for the benefit of user operators, and suggestions are welcome. We try to send these out and get them reviewed initially, and we need to follow up and see if there's new people, new ideas, and new thoughts, new experiences. All right, so now moving on to the last section here. I see it's a little past the half hour. Air and leakage guidelines is in progress. So what we wanted to do with this was have a guidance document specific to air-cooled condensers, because there's just a lot involved in air-cooled condensers that makes them more challenging than a traditional water-cooled condenser. I did a lot of air and leakage in water-cooled systems, and everything's indoors. It's just much easier. But ACC issues are specific. Now there's some good air and leakage guidelines, including the IOPS document and others that talk about air and leakage in a comprehensive way. Trying not to do that with this document, trying to refer to those documents, but just includes ACC specific items for the most part for this, so we can focus on that. So this is initial document. Okay, input from the relevant people. The product is will have technical information and examples of ACC specific locations. This is a big issue to know where to look. If you find a leak, a big leak, and you fix it, and then your air and leakage goes immediately down, you're done, or you could be done. If you don't find if you take several days and can't find the leaks because you don't know where to look, then it doesn't get resolved. So trying to find the locations where people have experienced leaks, so that testers can look in those areas first, is the highest priority of this document, really. And then issues to consider with ACC air and leakage, and then approaches for testing. These are the sections currently in this document, and again, we can add or adjust or expand on these. So that's what we have right now. You can read that. To just showing one of the problems with the air-cooled condenser air and leakage testing, the size of these systems. This is a frac tank down here in this corner. It's it's a very, very small structure from here, but it's really about 8 feet tall. And this duct here is 35 feet, over 10 meters in diameter, the main steam duct. And you can imagine trying to look at these flanges that are way up in the air, hanging out, and trying to get even to these tube areas and try to see there's just so much going on that makes it challenging. And that's before you even consider that you're outdoors and a 2-mile-an-hour wind is going to throw off any helium testing unless you're right on the leak. And so I know people who do this commercially. Air and leakage testing can take a week or two to go through an air-cooled condenser. just because of all the areas. So as you can imagine, that's somewhat costly as well. And again, looking at the where you want to test up towards the top of these structures, and they're 30 feet to 10 meters up in the air. Some of the things that can happen, these are the rupture discs. They tighten up when the system's under vacuum, and they generally work pretty well, but obviously they're a potential area that could show some leakage. This was a crack in some welds in an ACC that they put some sealant on it to try and plug those. But again, trying to find those, trying to find which of these tubes are leaking. And this is just one row of maybe 6 or 8 streets, and it is a challenge. This is another case where I think, if I remember right, some kind of an electro welding device accidentally got into this area and burned through the tubes. But a little diagram I showed in a past meeting where if you're doing the testing indoor, you spray a little helium, it drifts over towards the leak, and eventually it covers the leak and you get a signal. And it's fairly straightforward. If you're doing this outdoors, you spray a little leak, and the air currents that are blowing along take your helium away, and you can't do the same thing. You have to be right on the leak. You have to spray right on it in order to get the testing. So helium is probably still the most effective mode of leak testing, even with air-cooled condensers outdoors. But it's challenging and difficult. And then sometimes it shows up at unexpected locations. This is indoors. This is on a condenser, but see a crack in the wall of this condenser. And this was another one with crack in the wall. I think we're looking anyway. So these things, we don't really expect them to leak in certain areas, but could have a crack in a pipe that was completely unexpected. And another one. Again, this is the top of you see the flanges and the expansion joints in these areas. Getting access to these probably requires a man lift. You have to be raised up in the air to do that. And again, if you got 6 or 8 or 10 of these riser ducts, it's quite a time-consuming, extensive process. Again, just showing something that this is on the inside, but from the outside, it actually corroded externally. Some things that places you might have significant leaks that cause a lot of air and leakage. This is one issue that I think we mentioned the other day, but sometimes the deflagnators are cold towards the top where they're exhausting gases, and in that area, if you have debris accumulating, one utility, I forget which one, said they had birds building nests up in that area, and so when they would spray clean, or even when it would rain, the water would soak into that and cause corrosion on the tubes up in that area. Strategies: fans in the vicinity off, still air as much as possible, plan on getting close to the leaks. Some of the alternatives, and I wish I could talk more about these, but I just don't know that much about them. It's an area we need to look into further. Infrared testing, where the air is leaking into a system, it'll probably look cooler, so you should see a lower temperature with infrared camera. Acoustic testing is, I know that can be effective. There's a lot of noises, and both of these, I think, are good remote ways to do testing, so you don't have to be spraying helium right on the leak, but they're also, they require some expertise. They're not just, you don't just go buy an infrared camera and go find leaks. You have to learn how to use it, learn what you're seeing. And there may be other methods that to be considered. Excess AIL impacts plant performance by going in and settling in systems on sections of an air-cooled condenser, and then that's not available. The steam doesn't access that area and cooling, so you get increased back pressure. Systems with feed water heaters, that's a different scenario typically, but that could happen in a once through unit if you have feed water heaters, deaerators. Chemistry control, then oxygen will get in, and carbon dioxide, which can disrupt the chemistry monitoring and potentially have some corrosion impacts. Okay, so that's the status of the air and leakage document. I don't know if we have time to do a lot of talking about it right now. Things you'd like to include or cover or contribute, but I did send it out once and I will send it out again. And anyone who did not receive it and wants to can contact me, and I'll send the next draft out to them. But I'd like to get that done by the end of the year. And then the external inspection was a document we started on and got kind of bogged down because the scope is a little hard to nail down. And then prioritizing anything else that's a priority. I really like the discussion we had earlier about common ACC failure areas and prioritizing those. And that may be something we focus on for a little bit instead of another guideline, or we could work on another guideline. And anyone who feels compelled to initiate a guideline document that we can participate and contribute to is welcome to offer that as well. All right, I'm done with the documents and ready for any other questions or thoughts.
Thank you, Andy, for the presentation. Sean actually typed this question and he's explaining what he's talking about. So his question was at the base of the fins, at the base of the tubes where there's fins, there is a collection of like dust, dead insects, and when it rains, it becomes damp, promoting corrosion, which then causes the groove between the tube and the tube sheet header to open and cause air ingress. He's wondering if there's a way to cut the fins out to gain access to it, or would you just spray it with regular water?
So all I can think of is that in that area, if you cut the fins out, you're going to have a bigger gap for air to bypass the cooling. I'm not sure if there's something temporary that could be. I mean, if it's the entire bottom of the entire air-cooled condenser, it'd be pretty extensive gap. But no, there's nothing to do but clean it out and dry it out. And if that's not accessible, anything that allows that is fine, except that you don't want to end up with a bigger gap that lets more air bypass. So if that is a problem. The tubes I showed you with holes in them on the outside, that was essentially the scenario there at the bottom, and debris collected and the water was poor quality, and between all that, it caused the corrosion.
There's a comment about dry ice. Francis has used dry ice before. He says it's very effective, but we only did a small portion as a demonstration. Never pursued it further due to cost. So looks like dry ice cleaning is effective, but costly.
Okay, yeah, it's good to know it's effective at least.
There's a question from Greg Smith. With respect from air and leakage, have ACC owners, operators had success with helium leak detection, even though it is difficult and time consuming? Have any of the other methods been successfully used in the field? I know, so we had a really bad leak on our units. I think we called Conco thrice to detect it. All the 3 times we couldn't find the leak. In fact, when you do the initial test with the helium, you open up a tap by on like the vacuum side of the steam duct just to make sure your equipment's working. But the leak was so bad, it seemed like we couldn't even get the first hit, the first hit of helium, because it looks like the leak was so bad where the helium was diluted with the air ingress. And I know we were running the hogger all the time, like during regular operation because there was so much air and leakage. And then the Conoco guys kind of struggled because they need, instead of the hogger, they use the air ejector to detect helium. So the way it works is you go around, spray helium, and they have a tube hooked up to their air ejector or air jets to pull a sample out and see where you can get a hit of helium. But what I did try was an acoustic gun. So the struggle with that is that everything else, like there's a lot of noise in the plant, right? There's steam, air, compressed air. So that kind of results in a lot of noise. But if your unit is down, you can have the operators pull vacuum and go around with the acoustic gun, have them shut off all the pumps so it's quiet enough for the acoustic gun to pick up any leaks. And I think there was a couple of leaks that I did pick up on the ACC, the outlet header. So that works. But apart from that, Andy, are there any other methods that you've heard of for air and leakage? You detect air and leakage successfully?
So we did one time have a guy who was pretty good with the IR camera came out and went around, and he identified 5 or 6 spots that seemed like they might have leaks, and then we followed up with helium going to those specific spots. None of them actually turned out to have leaks, and we did not particularly know that we had any big issues with air and leakage at that time. There was something showing, but so I don't know. It's just I took the camera and I pointed it at a few things, and colors kept shifting, and I didn't know what I was seeing. And I think if you know what you're doing, you might be able to help. But it didn't actually show us what we were looking for. But I've heard people do that, and I've heard people say they had some success with acoustic as well. Not many. I think most people either call in a contractor or use helium themselves.
I know one way to save on the overall air and leakage testing is have the plant buy the equipment, and then if you guys have a leak, then you can contract and just pay for labor and travel, which cuts down the cost pretty. It's a pretty significant cost saving. So at the facility here, we own our own helium testing equipment, but if we suspect a leak, all we do is just pay the contractor for labor and then travel and lodging and stuff like that. So
Yeah, and I would think that if you wanted to really cut costs and you had personnel available, you could have one contractor, one expert come and get help from the plant if that's.
yeah.
Yes.
Barry has a question. Barry, go ahead and ask your question.
Yeah, well, I have 2 things. Andy already mentioned it, but all those different techniques are included in the IAPS document that's freely available on the website. And as Andy's indicated, we're not going to reproduce, but the information on those techniques that you've just talked about are available. But what I really wanted to indicate was there was a question earlier when in the middle of the presentation asking about bare metal being the indicator of in shown in the because that's not possible thermodynamically, but there is a relationship between
Hey Barry, we can barely hear you. You're cutting in and out.
And FAC, because when corrosion and FAC take place, it's metal. There has to be some oxide on it. So, just Arish, you just moved on.
Oh, okay. Okay. So Sean has a follow-up question about the air ingress at the base of the tubes where there's corrosion. So he's saying to seal those air ingress at the base of the tubes and the tube sheet header, what product would you recommend? We've tried DevCon. Is there any other product you recommend to seal air ingress? That was a question for Andy.
Oh, I thought it was a question for everyone.
Yeah.
Yeah, I guess yeah. If there's any users that have.
I don't have any specifics. I know one of the companies gave me some information a while back on something that was successful, but I don't have that right offhand.
Any other users have experience with using a sealant of some kind? Doesn't look like it. One question for Andy is, I would think that a guideline should include comments on fixing wind-related problems such as fan blade damage, fan bolts, and performance. Consider windscreens to solve these issues, and I would be happy to initiate some verbiage on this. Not sure where it fits into the guideline.
Good.
I think a guideline that's called addressing wind issues in air-cooled condensers could be really useful.
Okay. Follow up on the seal question. Francis uses leaks using silicone, and then blanks the tube off during the shutdown. So I guess silicone should work. You know, hopefully it will solidify by the time you start up and not suck that stuff in. But that's what I've used, a regular silicone to seal the pinholes. Any other questions on or any discussions that the users want to have on any topic? Now's the time to either raise your hand or type it in the chat.
I always maybe I can raise this up now.
You're saying something, Riyad?
You can hear me?
Good.
Yeah.
Yep.
Okay. We always have this question coming up as far as on hot days, if we can spray water under the air-cooled condenser or inside the cell. We always recommend not to do that. Do you guys have any additional comments you want to bring up?
So they spray water like on the ground where.
No, under the cell, under the ACC fan, spray water there, and then the fan air will pull it up. Yeah.
What kind of results do they get, Rian?
That's what I don't know. That's what I've been asking. I've been asked that question a lot, but we usually don't recommend spraying water inside the cell for corrosion purposes on the bundle, collecting dust and plugging those bundle tubes. So or the air pins. So is there anybody that have been testing this? What's their experience?
Have any other users sprayed water on the where the air goes in on top of the fan?
Or under the fan?
Or under the fan.
Yeah, well, it's, the misting systems are, even if they develop a really fine mist, I don't remember, Riyadh, did you see the Midlothian plant when we went
No.
to Dallas?
No.
Okay, they had like 67,000 nozzles with a very fine spray underneath the fan. And even then, some of the water would drop back to the ground. It's very difficult to get optimal use of that. Now I know you're you're urgent and you're not, you want to get the temperature down, the back pressure up and or down, and it's just it's probably not a big deal for a couple of days short term addressing, but you just don't want to be spraying water on there continuously. Now, Midlothian and another plant that does this uses demineralized water, so they're pretty safe with that. But still, you can see it collecting and dripping back to the ground. It's just an inefficient use in terms of a long-term mode of improving performance.
There was extensive testing done on this under the sponsorship of EPRI and the California Energy Commission at the old Bighorn plant back many years ago. And those reports are still available through the California Energy Commission.
Where they sprayed water?
Yeah. And I mean, it wasn't just a one-off test. It was several weeks of careful testing. And we didn't use the large number of very small nozzles. That system, really is fraught with difficulty. We used 5 gallon per minute nozzles, and they were up there, and they were placed around in a single cell, and we were able to get pretty good performance measurements. Andy is exactly right. If it's a very inefficient use of water for a long-term solution. But if you've got just, say a couple of odd hours in the summer, it's a very cheap and effective way to do it.
Interesting.
Okay, good. Do we have that document or study available? We can share it.
Well, these are publicly available reports through the California Energy Commission. I don't have the references at the top of my head. I will send those citations to Andy and he can distribute it.
Great, thank you.
Okay, yeah, maybe we could post something like that on our website. That would be of interest. Thanks, John.
Any other questions or discussions that the users want to have? Looks like we're on the top of the hour. Yeah, if there isn't anything, Andy or Barry, Riyadh, any closing comments, closing remarks? Thank you all for your participation. Really appreciate it.
Yeah, I just want to thank everybody for participating in this conference, and thanks guys for supporting us. Thank you.
Yep.
Yeah, I know some of you have worked with a lot of virtual meetings. This is really the first one I've been sort of running or over participating actively and setting up. So went really well, and I hope we don't have to do it again, but it was very nice this time. Appreciate everyone's participation. Yeah.
Yeah, it keeps the people involved. And I took a note, there's been over 70 people all the way through until the last 5 minutes. So that shows the participation has been good.